Welcome back to the workshop. We are still working on this AB165 Bassman, and I did figure out what the problem was. You'll probably remember at the end of the last video, I thought that I had solved the squealing problem that it had, but it ended up being something completely different than I thought it was, and it came right back. It turns out it was one of the preamp tube sockets. I replaced all four of those, and that squealing completely went away. I have not heard it since then. And the new sockets definitely feel a lot more secure. They're not wobbling at all. Nice firm contact with the pins when you push the tubes in. And so after that was resolved, then I played through it a bit. Just did a quick bias, just good enough to know that I wasn't going to red plate the power tubes, and then played through it a little bit. And I was getting a really strange oscillation in the power tubes, and I knew it was coming from the power tubes because it would only happen when I had the triode pentode switch on, which was it, triode mode. When I had it in pentode mode, or no, I think it was the other way around. Well, anyway, if I switched if I put the switch in the other position, it went away. So I knew it was something in the power tubes. And I also noticed when I was biasing it that if I turned it up, if I turned the bias pot up past a certain point, one of the two power tubes just, the meter wouldn't go up anymore. So the other one would continue to bias hotter, but that one just stayed right where it was. So it was pretty clear that there was a bad connection in that socket. So I tightened those pins, that oscillation went away, everything's good now. So I have also replaced the those brown turd capacitors and the phase inverter have been replaced with the orange drops that I ordered. And I know I said I wasn't going to use any of those generic polypropylene caps, but I ended up replacing the third capacitor with the generic polypropylene capacitor. The other two have orange drops now, but that third one doesn't seem to have any purpose in that amplifier. It's completely pointless. It's for the negative feedback coming off of the output transformer secondary. There's no DC coming off of the secondary of the output transformer, so we don't need that capacitor there to block the DC. So what's it doing there? Well, we see that sometimes in resonance controls. What your resonance control is basically like a presence control, only instead of bleeding off negative feedback in the higher frequencies, it is only allowing negative feedback in higher frequencies through. So you use a capacitor value in line with your negative feedback that is small enough that it blocks some of the lower frequencies. So those lower frequencies have no negative feedback, thus making them louder. That's your presence control. In this case, and I'll have to look at another schematic again, but I can't remember what value is typically used, but I would think that a 0.1 microfarad capacitor would pass all audio frequencies, which means that it has no sonic effect in this amp either. It's just completely pointless. I don't know why Fender put it in there. Those of you who know, comment below. Let me know why it's there. I'm curious if Fender just blindly copied someone else's circuit without thinking about the component values or what. But at any rate, I didn't feel too bad about putting a generic polypropylene cap in there. Even if it becomes leaky over time, there's no DC to leak through anyway. So, but I've drawn up a schematic on the whiteboard here, just to show you what's what of those three capacitors that were replaced. So the reason that I decided to replace that third capacitor is because those brown capacitors are covered in some kind of wax. And over the years, they've kind of left their capacitor snot on the circuit board. And, you know, I did my best to kind of clean some of that off there, but they were just sticky and they needed to come out. That third one needed to come out too. So, but anyway, here's the phase inverter. And this is our input capacitor for the phase inverter. This one got replaced with an orange drop. This is the other one that got replaced with an orange drop. This is the second input of the phase inverter. Now, the long-tailed pair phase inverter is also known as a differential amplifier because it amplifies only the difference between these two inputs, which is why this one is tied to ground. So because this is tied to ground, anytime we have a positive voltage swing on this input, it amplifies the difference between that positive voltage swing and ground, which means that you get a negative voltage swing at the second output. Whenever this goes negative, the difference between that negative and ground becomes a positive voltage swing, which is why one pushes when the other one pulls, and you get two identical but out of phase signals. So this right here, this is where that negative feedback capacitor comes in. And this is coming off of the output transformer secondary, coming through I think it's a 47K resistor, and then going through this capacitor. So, because there's no DC here, we could completely eliminate this, and it would do the same darn thing. So again, I'm not sure why Fender put it in there. If they had put a smaller value in there, then we would have gotten a really heavy bass sound, like if you had a resonance control in this amplifier. So right here you can see the two orange drop capacitors. I'll use my other hand so I'm not blocking you. These are the two input capacitors of the phase inverter. And then this third one here is that generic polypropylene capacitor that's just for the negative feedback loop. So we've solved the noise problems, got those capacitors switched out. So what I'll do next is just give all these pots and jacks a good cleaning with some contact cleaner, and then I'll do a final bias on the power tubes and we'll have a sound test. Okay, we got about 455 volts on the plates, and these 6L6s have a max plate dissipation of 30 watts. So we'll do, come on calculator, okay, 30 divided by 455, and I want to bias this at about 60% because these tubes tend to run kind of hot. So times 0.6, and we're looking at 39 milliamps per tube. And we're actually not far off from that. We're biased slightly colder than that. And boy, I can already feel a lot of heat coming off these power tubes. So I definitely don't want to go any higher than 60% or 65%. So this one's about 20, what does that say, 27, something like that, 26, 27. This one's right at about 32. So we'll bring this up just slightly. And right about there should do it. You know what? That's odd. I wonder if I've got a bad meter, because look, this still isn't rising. Look at that meter. I'm going to have to look into that. Weird. Maybe a bad connection or something. Well, anyway, those are biased at about 60% now, so now we can give this a listen. Alright, I've got the speaker output on the amp going through a attenuator with on the minus 6 dB setting, and it's going into a 16 ohm creamback speaker. I didn't have a ohm speaker around here that I could use, so the 16 ohm will be just fine. I believe this is on triode mode right now. Yep. Okay, so this is triode mode. see. Turn the treble up a little bit. Had the mud switch down. So there's triode. And here's pentode, and I apologize if there's a lot of clipping on the camera mic. I don't really have a way of miking the speaker up over here, so. Pentode. Triode. So you can hear the triode mode is a little bit darker sounding and just a touch quieter. There's not a huge difference in volume. So that project is finished. I hope you enjoyed it. And by the way, the preamp tubes are still the original. The two of the preamp tubes are still the original tubes, and the other two are 12 AT7s currently, because that's what I had. So I haven't ordered the new preamp tubes yet. I am going to. I talked to the owner, and I'm going to order a full set of preamp tubes. So yeah, the preamp will have a little bit more gain than it does right now, but you know, at least this, those of you who are familiar with this amp, I'm sure you can tell this is what it should sound like. Great sounding amp, a little too much for this little room, a little too much for that camera mic, but nice amplifier, and I've enjoyed working on this one, and hopefully you've enjoyed watching this. Thank you again to all the people that have commented in these videos. Keep them coming, and so that's it. We'll see you in the next one.